Okay, so we're going to talk about the second problem, spiral matrix 4 of this weekly contest 300. Okay, so yeah, so this problem is really very much simple. All you have to do is you have to generate a matrix with the given spiral order linked list. Like the linked list is actually given in a linear fashion, but it denotes the elements of the matrix in spiral form, right? So we are given two integers m and n, which represents the dimensions of a matrix. We are also given the head of a linked list of integers. We have to generate a m into n matrix which contains the integers in the linked list presented in spiral order. Okay, so basically the element we have a suppose we have an elements of matrix and we have generated the spiral order of this matrix, and that spiral order is actually being denoted by this linked list that will be given to us, and we have to generate the matrix from this linked list, this spiral order linked list, which is actually it represents. So we have to generate a matrix basically. Yeah, so that contains the integers in the linked list presented in spiral order clockwise, starting from top left of the matrix. If there are remaining empty spaces, fill them with -1. Okay, it does not contain the entire elements of this matrix. Like some of the last few order, that like if you find out the spiral order of this matrix, last few elements would be -1. That will be denoted by this linked list. Like their occurrence will not be present in this linked list. Okay, if you're not getting it, no need to worry about. I will explain all that with the help of examples. Okay, so this is the very first example, this is second one. Okay, so let's look over the constraints. Like you can see, the total number of elements m into n will be less than equal to 10 raised to the power 5. So you need to have an efficient way to generate the spiral matrix, like o of m into n time. You need to do that. Okay, so how we are going to do that and all that, let's understand this one with the help of examples first. Okay, so this was for the previous problem. Okay, so suppose we have a matrix like 3. Okay, so 3 5 5, and again 0 2 6 8 6 8, and we have 0 -1, and again -1 followed by 1, and 2 4 9 7 2 4 9 7. Okay, so when we have been asked to find out the spiral order of this matrix, you can see we will start from the top left, that is from this one, then we will move out to this one. Okay, so let me do it fast. This one, this one, this one, this one, and now when you reach the top right corner of this matrix, you will move out to the next row, that is quite down up here. So you will go to right one, right over here, and when you reach the bottom right corner, you will move to the left one, and when you reach out to the bottom left corner, you will go up. Okay, now you when you reach 5, you're not going to visit 3 again because 3 is already visited. So you will go to the right, like this one. Okay, so now you can see when you are at this one, there doesn't exist any unvisited elements, so you are going to stop. So your spiral order traversal would be something like go to the right first and try to explore all the elements as far as possible. When you are done, go to the down, try to explore all the elements as far as possible. When you are done, go to the left, and similarly go to the up. Then something like this one, 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 like that. Okay, now you are given the head of a linked list. It means that you are given the head pointer, we have a linked list, and the head pointer is going to denote this one. This will be head pointer. Okay, so this linked list will be storing the spiral order of this matrix, and we need to generate that matrix from the given linked list. Okay, so it means that you need to iterate in the linked list and extract out the values and fill out the values in the matrix. Obviously, we are going to do that. So, but while doing that, you need to have the spiral traversal in this matrix then only you are going to map out the values, like extract out the values from the linked list and put it out in the matrix at the specified position. So in that case, you need to have a spiral order traversal in the matrix. So let's understand how we are going to traverse this matrix in the spiral fashion. Okay, so let me just generate the sufficient background. Okay, so okay, so let me just make some boundaries of this matrix. Let's say this one. Okay, so this will be the boundaries of this matrix. I hope the screen is quite visible. Okay, so for this we need to traverse in the matrix in the spiral fashion. So what I will do is I will initialize four variables. X1 will be positioned as 0, and x2 that will be positioned as n minus 1, and similarly y1 will be positioned as 0 and y2 will be positioned as m minus 1, where n and m are the number of rows and number of columns respectively. Now what is the reason behind doing that? Behind doing that is simple. You It suggests that when you are at x1, like, okay, so let me denote it clearly. When you are having x1 and x2, it means that currently you have uh, the number of rows exactly equal to x2 minus x1 plus 1, and it starts from x1 is are unvisited. Like initially x1 denotes 0 right over here, and x2 denotes n minus 1 right over here. It means that there are exactly 3 rows which are still unvisited, and it starts from the row equal to x1, right? And for the corresponding case y1 and y2, it says that we are having unvisited columns starting from y1 and going up to y2, right? So initial variables will easily denote that yes, we have these elements being unvisited. Okay, now for each iteration, we will try to visit it circularly. Like for exactly one iteration, we will call it as visit to the right, visit to the down, visit to the left, visit to the up. This is called one iteration right over here. Okay, and for the second iteration, we will start with over here. Go to the right, go down, go left, go up. Now our second iteration ends. And again, our third iteration starts with the top left of unvisited cells. Go right, go down, go left, go up. This is the exact way that we are going to do. Okay. So currently we will start from this position, which will be our x1, comma y1, right? And we will iterate up to y2, light up to here. And when we are done, we will try to increment x1, because now our new row, which is unvisited, would be starting from here. So we will increment our x1. So we will write down x1 plus plus, and after doing that we will iterate up to x2. And when we are done with this one, you will decrement y2 minus minus, because we are done with this column, that is y2. So our new y2 would be starting from here. Now again we are going to move to the left, and when we are at this left position, we will decrement our x2 by 1, that is x2 minus minus, because we are done with the last row that is still unvisited. We are done, so we will decrement x2. Now we will go up, and when we go up, we will increment our y1. Why will increment our y1? Because we are done with the very first column. So after doing that, you can see our next iteration, that is second iteration, that is being defined over here, will start from this position. Now it goes well. You can see we are traversing this matrix in spiral form. Okay, so let's head over to the code to understand the implementation in detail. Okay, so why not I should move out to my submissions when I submitted this one in the contest. Yeah, that looks good. Okay, so we are going to initialize our answer matrix as size of n into m, and it is filled with -1, because the head of the the link list is may be complete, may not be complete, and the rest of the elements are filled with -1. So it is better to initialize our matrix that will be generated as -1. So we have four lines x1, x2, y1, y2, right? So we will initialize x1 as 0 and x2 as n minus 1, y1 as 0 and y2 as m minus 1. Okay, where n and m are the number of rows and number of columns respectively. Now we are going to do the spiral order traversal till our head, which is the head of the linked list, is not equal to null pointer. So we will initialize j as y1 and j goes up to y2, and we will do that till head is not equal to null pointer, and we will increment our j each time. Now you can see this is basically that this traversal, right? So this is what I'm going to do over here. Note that the we may exhaust our linked list, like the linked list may be completed at any position, right? After that all the values filled with -1. That's why we need to mention this condition, like this condition is important, otherwise you will get a runtime error. Okay, and after doing that you will increment your x1, which is move out to the next row. And now this is for this y2 position, this traversal. You can see iterate from x1 to x2 until head is not equal to null pointer, and generate the matrix, put out the value, and move your head pointer to the next position. Similarly for this, like y2 is decremented, now go for this position x2. You can see answer of x2 and g is assigned with heads val, and move out to the next pointer. Okay, and decrement x2. We are done with this last row. Okay, now go up. For this one you will encounter y1, and when you are done with this one you will increment y1 also, and finally return the answer, which will be our generated matrix. Okay, so yeah, so the time complexity of this solution is O of n into m, because we are iterating uh, till O of n into, like, for each matrix occurrence, for each matrix element we are going to iterate up to that. So time complexity will be O of n into m, like each element is accessed exactly one time. So time complexity is O of n into m. And what about the space complexity? Space complexity is O of n into m also, because we are making an extra answer vector to store the answer of size n into m. Okay, so if you guys have still any doubts, you can reach out to us through the comment section of the video. And thank you for watching this video.